Hi, my name's Lee. My talk is about tools for understanding Go module dependencies. I'm going to start with a brief recap on what Go modules are. Then we'll dive into some tools that will help us understand dependencies of Go modules. So Go modules is the name given to how dependencies get managed in Go. A Go module is similar to a Node package or a Ruby gem or a Rust crate. It's really a collection of one or more directories of code files and then their dependencies. A Go module defines its dependencies in one file, and that's the go.mod file. So if you work in a relatively modern Go code base, there's a good chance that there's a go.mod file at the top. That go.mod file contains a list of dependencies that the application has on other libraries. Let's have a look at a go.mod file. So in one of the projects I work in, the Stellar Go monorepo, it has a go.mod file, and we can see that there's some other information in here, but most of the file is a long list of dependencies, versions of those dependencies, and then we can see that some dependencies have this comment on the end, this indirect comment, which we'll come back to. So for the most part, this is everything that you need to know for 99% of your day-to-day development in Go. Everything appears to the work the way that you would expect it. New dependencies will show up in this file. Dependencies you don't use anymore will disappear, and everything will work. But there are some things which will likely become gotchas, and so we're going to have a look at those, and then look at some tools that will help us understand our dependencies better. So the first gotcha is that go.mod versions, or the versions in the go.mod file, aren't necessarily the versions that will be compiled. So if you're building a library that has a dependency and you specify a version, that version in the go.mod file is the minimum version that your library needs of that dependency. So if your library is imported into an application that has other dependencies, those other dependencies might require a new version of your dependency. So what actually gets compiled may not be the version that you see listed in the go.mod file. The second gotcha is that go.mod doesn't tell us about all our dependencies. The go.mod file is only intended to capture direct dependencies and not the dependencies of your dependencies. In some edge cases, like we saw when we were looking at that go.mod file, you will see some dependencies with an indirect comment. And those are indirect dependencies, but they only show up for dependencies which don't have their own go.mod file. There has to be a go.mod file that specifies them somewhere. So if your dependency doesn't specify them, it's going to end up in your go.mod file. But you can't rely on that. If you import a dependency that has a go.mod file, its dependencies are not going to show up there, so you're not going to see them there. So a go.mod file is not a snapshot of all your dependencies of your application. And the last thing is that if you do have indirect dependencies, your go.mod file isn't going to tell you anything about why you have them. So usually it's pretty easily to work out why you have a direct dependency, because you can look in your code and you can see that you import it. You can see where you import it. But for an indirect dependency, it might be more difficult to find out why it's being pulled in. So a go.mod file won't tell us anything about why we have the dependencies we have. But there's good news. We have tools. There are tools built into the Go toolchain that will tell us all of these things. So let's have a look at them. So the first tool is the Go list-m tool. This command is really powerful. It has a lot of options and it can tell you a lot about your Go code. One of them being what all of your dependencies are, including your indirect dependencies. Let's have a look. So if we go back to our repository, we can run the command go list all, and we'll see it gives us a long list of dependencies. Now, if we compare that, let's compare that with the dependencies that are listed in our go.mod file and see how different they are. So if we get a, I'm just going to get a list of all of the imports, all of the dependencies in the go.mod file using the mod edit command. That's just going to give me a JSON version of that. And then I'm going to use JQ just to pull out those dependencies and count the number of lines we have. Okay, so there's 87 dependencies listed in our go.mod file. Now, if we run the go list command and also count the number of lines, we can see 147. Wow, okay, so we have 60 indirect dependencies which aren't listed in our go.mod file. This command is really useful to track over time. So you might want to commit the output of this into your repository if that's something that you care about. It's something that I do in some of the repositories I work in. But yeah, this command, you can use it to find out what all your dependencies are. So the next tool that we're going to have a look at is the go mod graph tool. So this command does one thing, it has no options. It prints a line for every module, similar to go list, but then it also prints a line for every indirect dependency that that module has. So it sort of gives you this, this graph-like structure, so you can see all of how all of the dependencies relate to each other. Let's have a look on the terminal again. So run go mod graph. There's a lot more output here. If we go to the top of the output, it starts with the module we're currently in, the Stellar Go repository, and it lists all of the modules on the right side that it's dependent on. And then after that, it starts listing those dependencies and then their dependencies and so on. So it's quite a lot of output, but it gives you a lot of information. This can be really useful to help identify what dependency you're pulling in that's pulling in lots of other dependencies if you're trying to reduce your dependencies. Okay, let's have a look at the next tool. So the next tool is probably my favorite. It's the go mod y. So this command is for understanding why you have a particular dependency. It'll tell you which packages within your module are importing the dependency, and it'll show us the dependency chain as well. So if you run go mod y c and A imports B and B imports C, it'll show you that dependency chain, so you know why you have a particular indirect dependency. Let's have a go of it. So you run go mod y, and let's pick a package that we had seen just on screen a second ago, which I think was the gRPC package. Okay, so we can see that we have the gRPC package. It's not a direct dependency, it's an indirect dependency. The direct dependency is the API option package that Google has that we're dependent on. And it would also show us like what package within our project is using that as well. The command also has a -m option, so go mod y -m, and that will give you, that'll show you the dependencies that the project has on any package within that module, not just a specific package. So a good example of that, I think, would be the Testify package. I know this project is dependent on the Testify test framework in some of its non-test code. So if we run this command, we'll see, oh, it doesn't think that it's dependent on it. But if we add the -m, we'll see, actually, I actually have a typo. It's not stretchy, it's stretcher. Okay, but then if we add the -m, we will see that, okay, we're actually dependent on the assert package within the Testify module. Finally, the last tool we're going to have a look at is the go list compare tool. So this command isn't built into Go. It's a command that we created at the Stellar Development Foundation for use in our Go repositories. It generates easy to understand comparisons for Go list outputs. So that very first command tool that we use, the go list -mall, if you generate that, if you run that on a repository and get that output, and then you upgrade the dependencies of the repository and run it again, this tool will give you a nice formatted output of here all the dependencies are changing, as well as links to diffs of those dependencies, so you can actually have a look at what new code are you bringing into your package. Let's give it a go. Let's have a go of that. So the first thing I'm going to do using this tool, to install it, you need to use goget because it's not a built-in tool. So you can run goget and then get it from that URL. And then before we use the tool, we need some go list output to compare. So we're going to run go list -m-json. Also, we're going to get the JSON version of the output for the tool. So let's just call that go.list.before. And then now let's upgrade a dependency. Let's upgrade the testify dependency and see what we get. Okay, so that was pretty quick. It's pretty small number of diffs here, but we can run -m all -json all again. And we'll give it both of those files to compare. And it'll give us some output here, which isn't too different to the output above, but it gives us these links that we can go and follow. We'll be able to see the diff that's being introduced there. It's also showing us that we're adding a new dependency that we didn't have before. Let's try the same thing. Let's get rid of those changes we just made. Let's try a more complex dependency. So let's go get, just have a look in the what we have. Okay, let's try upgrading the Firebase dependency. It's a big SDK, so chances are it has a lot of dependencies, and upgrading it might require a lot more changes. Okay, so there we go. So the command has actually told us that it's upgraded a few dependencies here. Not too many. They fit on screen, which is interesting. I thought there would have been more. So let's generate our new list file. So that we actually forgot to generate the before file. So I'll generate the after file now. And I'm just going to remove all of those changes that we made upgrading. And so this is doing it a little bit backwards, but I'm going to go generate the before. So it doesn't matter what order we generate them in, because the go list compare tool is just comparing the output and not doing anything else with the repository. So, okay, let's run go list compare again on the before and after files and see what the output looks like now. Okay, wow, so it actually says that there's 61 dependencies changing. The dependencies are numbered on the left, and we can see yeah, there's quite a lot of dependencies here. So this is really helpful for understanding not only what direct dependencies are being upgraded, but what indirect dependencies are being upgraded. All the dependencies, there's a line for each dependency that's changing. It tells us that some dependencies are changing one version to another. It's telling us that we're adding some new dependencies. For dependencies that it recognizes are hosted on platforms like GitHub, it's giving us links so we can go and have a look at exactly what code is being updated there as well. So to do a quick recap, there are 4 tools that you can use to understand what dependencies you have and why you have them. 3 of them are built into the Go toolchain. If you're interested in some further reading, there's a blog post by Alex Edwards that talks about a lot of the different Go tools, which I found pretty helpful. There's the official Golang reference for the mod command as well, and for modules, and there are some other links there for some of the history and more detailed if you're curious on like why do Go modules work the way they do. Thanks.